Hello Calculus kids, hope you're doing all right. This is going to be our video over 5.4, exponential functions, differentiation, and integration. I'm actually going to be splitting this video into two parts. In this video will be part one, where we're going to be talking about differentiation of the exponential function e. So in other words, today we're just going to focus on how to derive the e function. So let's go ahead and hop to it. Here are the objectives for this lesson for video 1 and video 2. You guys can read that on your own some other time. So now, how to derive or find the derivative of an exponential function. So, the best way to derive e is, the first thing you want to do is you want to take a look at its power. And whatever the power is, I want you to derive that. So in other words, take a look at the power and take the derivative of that. So in other words, the derivative of 12x, which is just going to be 12. That's going to be part one, deriving the power. Then what's going to happen is that you're going to take that and multiply it by what the original function looks like. Or in other words, you'll multiply it by the whole function. In other words, you multiply it by the e 12x. And once you do that, then you basically have your derivative. Your derivative is going to be 12 times the original e12x. So 12e to the 12x. That's it. You literally take the power, derive it, and then whatever that is, multiply it by what the function was before. And that's it. That's how you derive an e. Let's do a couple more examples like that just so you can get the hang of it. So for this example, we're going to take the function e to the 7x, and we're going to derive it just like we did. First thing, I want you to take a look at the power, and I want you to derive that. So derive 7x, which is just going to be 7. And then step 2, you'll multiply that by the original. And I'm not saying just the 7x. I'm saying the whole thing, the whole original function, e7x, the entire thing. So then multiply those two, and you'll have your derivative, which in this case will be 7 times e to the 7x. Done. Second one, very similar to that. Anytime you have to derive e, first thing you want to do is look at the power. In this case, we'll derive the power. We have the power is negative 5x cubed. So multiply the 3 to the negative 5, and that's going to be negative 15. And then subtract 1 from the original power, which will give you x squared. So that's the derivative of the power. And then multiply that by the original. And the original is all of this, e negative 5x cubed. So there you go, multiply those two and you have your derivative, just like that. Negative 15x squared times the original, which in this case will be e to the power of negative 5x cubed. All right, so now you understand the basics of how to derive the e function. Now let's apply it to some other examples where you might have to use the product rule, quotient rule, chain rule, all that stuff. So the next example we have e that has a power of the cube root of x. But as you guys know, if you need to, you can rewrite the cube root as a power. So in other words, you can rewrite this as e to the power of x, where x has a power of 1/3, where 1 is the power, 3 is the root. You guys got plenty of experience with that stuff. So now that we have it rewritten like this, it'll be easier to find our derivative. So just like before, you're going to take your power and you're going to derive it. So just like in any derivative, you'll take the power multiplied to the front, which will give you 1/3. And then you got to subtract 1 from the original power. So subtract 1 Or, probably to make it easier, subtract it by 3/3, which is the same thing as 1. So then 1/3 minus 3/3 will give you a power of negative 2/3. That was not properly written. There we go. So that's the derivative of the power. Then you just multiply by the original. In other words, the whole original function, which we have over here, which is e to the cube root of x. All right, but probably before we multiply these, we should actually simplify. Or more specifically, we have a negative power. We did not start with a negative power, so we shouldn't end with negative power. So to make it positive, let's put it on the bottom with the 1/3. So it'll become 1/3. The x will go on bottom and become x to the negative 2 cubed. And we're still going to be multiplying that by this, by the e cubed root of x. Of course, we're not done yet. Oops, I made a mistake there. That was supposed to have been x to the positive 2/3. There we go. And also something we should do, since our function started with the root, we should rewrite it so that it ends with the root. So when we rewrite it, give me a sec, gotta make more space. So when we rewrite it, the 3 on bottom will become the root, and then the 2 on power, or on top, will be the power. So it'll be the power of x, or x squared. There we go. So now we have 1 over 3 times the cube root of x squared. And this is still going to be multiplied by 3 to the power of cube root of x. And when you multiply these, it might make it easier to rewrite it, the e as over 1, and then you just have to multiply horizontally. On top, 1 times the e, well, that just gives you the e, so e cube root of x. On bottom, all this times 1 doesn't change, so on bottom you'll just have 3 times the cube root of x squared. And there you go. So just applying some stuff that you have already done before, only this time we're using the e stuff that we just learned. If you have any questions on this, please let me know. I can re-explain it via Google Hangouts or email. Just let me know. Okay, so now moving on to the next example, we need to find the derivative of the following function. And you probably recognize that we have 2 parts being multiplied. And multiplication means product, which means we gotta use the product rule. So let this be A and let this be B. The product rule is A prime times B plus B prime times A. You guys should probably memorize the product rule in your sleep. So now, let's use the product rule. Let's first do A prime, or in other words, do the derivative of A. Derivative of 8x is just going to be 8. And now, A prime times B, where the B is just EX. And then plus, now we got to do B prime. So in other words, we got to take the derivative of B. So in other words, first, take a look at the power. Whoops. Take a look at the power and derive the power. Or in the derivative of the power x is just 1. And then take the original. The original is just EX. So that's the derivative of B, it's just 1 times EX. And then lastly, we just put A, where A is 8x. All right, you just got to simplify the rest from here. Here, we'll do 8 times EX to give you 8EX. And then we'll add that to this. First, we'll do 1 times E to get EX, and then multiply it by 8x. And usually, formally, what you want to do, most mathematicians will formally write it so that the EX is in the back, and then anything being multiplied is in the front. So let's go ahead and rewrite that as 8x times EX, where the EX is in the back. And sadly, we cannot add these together, given that the 8 and the 8x are not like terms. So sadly, these two cannot be added. And thus, we leave it as is. This is the derivative. So again, just doing the product rule, things you've already done, just now we're using it with the e function. All right. So moving on to the next example. Now we got to find the derivative of the following exponential function. So in other words, we're just deriving the e. So the first thing you want to do is take the derivative of the power. Ooh, we got a fraction here. And a fraction is the same thing as a quotient, which means we got to do the product rule. So, show you how to do the product rule. So we got negative 4x squared as our power, where this is the high and this is the low. And just getting a refresher on the quotient rule. First, you got to do the low times derivative of the high, minus the high times the derivative of the low. Whoops. High times derivative of the low, and then bottom squared. So let's go ahead and do that over here for the power. So my low is x squared times the derivative of the high, derivative of negative 4 is 0, minus the high, where the high is negative 4, times the derivative of the low. The derivative of x squared is 2x. And then we take the bottom, which is x squared, and we square it again. So that's what that is going to simplify to. Then we multiply that by the, whatever that is, we'll multiply it by the original function, where the original function is all this. So e to the power of negative 4 over x squared. So let's simplify that and go from there. Make a little more space. So first, over here, when we simplify the power part, first we'll do x squared times 0, which is just going to be 0. Don't need that. And then here we got minus a negative that will make that plus positive. So now you just got to do 4 times 2x, which will give you 8x on top. On bottom, 2 squared raised to a second power makes that x to the 4th. And that will be the simplified power. And then over here, we're still multiplying by the original. And some of you can probably recognize that over here, the x's can reduce. You take 1x from the top and bottom, this one goes away, and this becomes x cubed. So now you just have 8 over x cubed, and now we're going to multiply that by this. So e to the negative 4x squared as a power. I'll rewrite that over 1, and then multiply horizontally, which will give you your derivative of 8 times e to the power of negative 4 over x squared, all over x cubed. So that's how you do that one, doing the quotient rule. And believe it or not, there is actually another way to derive this besides using the quotient rule. Let me show you how. I'm going to go ahead and erase this work. You guys can keep that work. I'm just going to go ahead and erase this. Now, some of you might have already realized that there was a faster way to derive the power. Because negative 4 over x squared, what if I took the x squared and flipped it to the top so that it became negative 4x to the negative 2? Then from here, I can do the derivative part by multiplying the 2 to the front, the negative 2 to the front to get 8, and then just subtract 1 from the power to get negative x cubed. Then, if I flip that back to the bottom, that'll give me 8 over x cubed. that would have totally worked as well. And then if you multiply that by the original, which is going to be e to the negative 4 over x squared, if you multiply those two together, you'll see that you'll still get the same answer. Miss Shulin, that way was so much easier. Why did you show us the quotient rule? As some of you might be thinking. I showed you both ways so that you could choose. Some people may not recognize that you can do this. They may not be able to see that you could do that quick trick. And if they don't recognize that, then they have to use the quotient rule, which will still give you the same answer. You can choose either one. And I do my best to provide you with choices, and both choices will get you the same answer. Okay, now that I've covered that one, we're good to move on to the next example. Oh, this doesn't look pretty. Gross, 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 gross. That's probably what you're thinking. And you can probably guess, we just used the product rule and the quotient rule. You probably know what's going to happen next. I have an orange peel, which means I got to do the orange peel rule, or the textbook calls it the chain rule. Okay, so let's do the orange peel. So, orange peel first, multiply the power to the front to get 2. Everything inside does not change. We're keeping that as is. And then subtract 1 from the power, which gives you 1. But of course, you don't really need a power of 1, so I'm just going to put that as is. So there you go. There's the orange peel. Now, we got to do the slices. And these are going to be the slices. And it looks like there's 2 parts we have to derive. We have to derive part 1 and part 2. And notice how both of those are e's. So in other words, the e's, we're going to have to do the power times the original, and then we'll add that to the second part, where we'll take the derivative of the power and then multiply again by the original. So let's go ahead and do that for the first one. For the first one, take the derivative of the power, which the derivative is going to be 1. Then multiply that by its original. And its original was 3x. So that takes care of the first part. Now let's look at part 2. Part 2, take a look at the power, find its derivative. And the derivative of negative x is negative 1. And then multiply that by the original. And the original is all of that, e to the negative x. Whew, oh boy. So just doing all of that was the slices. That was the whole derivative of the slices part. So now it's up to us to simplify. So for the first part, we still got this. We got 2 times e to the x plus e to the negative x. And then we're going to multiply that by the slices. First, we're going to have 1 times e to the x, which is just e to the x. And then we're going to add that to negative 1 times this, which will be negative 1 times e to the negative x. And also, if you don't want to write plus negative 1, you can go ahead and just put minus 1e to the negative x. And technically, you don't even need the 1. You can just put a minus, and it's still technically the same thing. All right, so now we reach this point. You're probably thinking, oh, okay, so I got 2 factors. I guess I can multiply those using FOIL or something. And technically, you could, but if you do, it's going to look really messy. Personally, I'm totally okay if you just want to leave it like this. If you want to leave it as e to the x plus e to the negative x and leave it as being multiplied by the second part, I'm totally okay with that. Just leave it as is. It looks yucky as it is. We don't want to make it even more disgusting. So, keep it as that, and then we're good. Okay, so we've done roots, we've done product rule, we've done quotient rule, we've done chain rule. What else could I show you how to do with E? Ah, I got it. what about natural log? How will we do natural log? If you guys remember from our little quiz, anytime you're doing the derivative of natural log, you take a look at what's on the inside. First, you'll derive the inside, and then you'll just divide that by the original box. Or in other words, this whole original box. So let's go ahead and try that. So we know that we're going to have to divide by the original. So let's write that on bottom. So on bottom we'll have 3 plus e to the 3x. But now, let's derive what's on the inside. Well, first, you're going to derive the 3, and the derivative of 3 is just going to be 0. And then, we got to derive the e. And just like with the e, you derive the power first, and then multiply by the original. So let's look at the power, derive it, derivative of 3x is going to be 3. And then, the original is everything, or everything that has the e. So e, 3x. Okay, let's simplify that from there. On top, you don't really need that 0, because 0 plus anything is just itself. So on top, you'll just do 3 times e 3x, and that's good. And then on bottom, you get this. All right. Now, some of you are probably looking at this and saying, ooh, can I cancel out the e's? So then I can do 3 over 3, and then 3 divided by 3 is 1. Can I do that, Miss Shulin? Can I? I know you're eager to do so. Unfortunately, we cannot. And here's why. The reason why is that only 2 terms have e to the 3x. The 3 does not. If the 3 had an e to 3x with it, then yes, you would totally be allowed to eliminate e3x from all 3 terms. However, since only 2 have them, you can't do it. That's the number 1 rule that a lot of kids seem to miss. Students are so eager to eliminate stuff. They are so eager to see something that can eliminate and to cross it out and make it look pretty. It's tempting. It's really tempting. And I understand. I made that mistake too. But unfortunately, the rules of fractions and additions do not allow it. Only when all 3 terms have the same thing can you eliminate. So, with that said, this is as good as it gets. So this is our official derivative. Okay, just wanted to clarify that. If you have any questions on that, let me know. And now we can move on to the last little tidbit of our video. Here are just a couple more examples if you wanted to try them on your own. The answers are right here, so you can check your work. Just extra practice if you want to do it. It's all right there. So now the last thing I want to talk about is the relationship between e and the natural log. It turns out that e and the natural log are actually inverses of each other. And what I mean by inverse is that basically they're like mirror images of each other. Or in other words, they share very similar relationships. Same curve, just reflected. Okay, cool, Ms. Shulin. These 2 functions are inverses, but what does that tell us? Well, inverses, another word for inverse is opposites. And you're familiar with how opposites work in mathematics, right? Like here I have -3 and +3. Those are opposites, and if I were to combine them, they'd cancel out. Here I have 5, and here I have 1/5. These are technically opposites. And if I were to multiply them, the 5's would cancel and the 1's would cancel. And so on and so forth. Basically, inverse is another way to say opposite, and opposites tend to cancel. Or in other words, anytime natural log and e are right next to each other, that means that since they're inverses, you're allowed to cancel them out. And all that you're going to be left with is the power that did not get eliminated. The same thing is also true for the other way around. Like, what if I e raised to the natural log of x? This basically means, since e and natural log are inverses or opposites, that means I'm allowed to cancel them out, and I'm just left with whatever was in the natural log. It's a very nice tool that is used a lot in calculus. If you know this rule, it makes your life so much easier. For example, let's say, well, we kind of already talked about this one. Let's say that we need to find the derivative of this. Well, I mean, yeah, you could do the derivative of the natural log, take the box on the inside and derive the box and then divide it by the original, and you would get your answer, so on and so on. You could do that. However, if you were to recognize that these two would cancel, since they're inverses, you would then be left with just x. And once you have x, you'll be like, I can derive x, that's easy. The derivative is 1. And then you're done. Then you can go play basketball or watch a movie or something. It's that easy. The same thing with the question over here. I mean, yeah, I could derive the e, I could take the power, derive it, and then multiply it by the original, and I could get my derivative, yada, 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 yada. But if you recognize, hey, these two are inverses, they're opposites, so that means I can cancel, and then I'm just left with 7. I can derive 7, that's so much easier. Derivative of 7 is just 0. I'm done. I saved so much space on my paper. I'm done. Trust me, it makes your life so much easier. If you remember those rules about e and natural log, that they're opposites and that they can cancel out, anytime they're next to each other, you're good to go. And with that, that basically wraps up derivatives of e's. So you can go ahead and tackle these few problems, and that takes care of the first video. You can go ahead and watch the second video whenever you get the chance. If you have any questions, just email me. And I hope to see you guys soon.